Good morning. Right triangle trigonometry. Last time we did the circle. Today we're going to look at the trigonometric functions on a right triangle. Okay, so recall for a right triangle. One of your angles is a right angle, 90 degrees. We're just going to look at this angle here, angle T. For our purposes, obviously we still have the hypotenuse, which is always the side that is opposite the right angle. Yeah. In this case, because of where the angle is located, the base we call the adjacent side. It's the side adjacent to your angle. The height is the opposite. It's the side that is opposite to your angle.
When was the test? I thought the test was today. Next Monday?
Monday.
I did the whole sheet, the sheet there. And this stuff is going to be on it too.
Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. And a common mnemonic that is used SOHCAHTOA. Then you have secant. Remember, that is just the reciprocal of cosine. So that's hypotenuse over adjacent. You have cosecant, the reciprocal of sine. That is hypotenuse over opposite. And cotangent, which is the reciprocal of tangent. And it's just adjacent over opposite. Identities are cofunction identities. Cosine of t is sine of pi over 2 minus t. Sine of t is cosine of pi over 2 minus t. Right? Sine and cosine are cofunctions. Then you have tangent and cotangent. And secant and cosecant.
So one of the B's we used, like with the right triangle as well.
No, they can just always be used.
Or why is it like a radical? Or why is it like a radian?
Because that is what you use by default as the angle measure. It's always radians. Unless specified otherwise.
Unless it told you to do like degrees or something?
Find the trigonometric functions of the acute angles for this triangle. So what we're doing here is essentially just solving the triangle.
So we know that one corner is 90.
Yeah, there's always going to be one 90-degree angle.
So then you can use that to do like. Like opposite over adjacent or something? Do sine.
And we don't have opposite, do we? If I start with theta. We're missing
Opposite. You're missing the opposite.
that length right there, right?
But then you have the adjacent hypotenuse. So you can do cosine.
Well, we can do all of them. First, I'm going to find that missing line. Given a right triangle, what is our favorite theorem for right triangles?
A squared plus B squared equals C squared.
What's it called?
Diagonal theorem. Oh, you can find the other side.
Every right triangle has to follow that. The sum of the square of the sides is equal to the square of the hypotenuse. What's the hypotenuse?
Is it not 25?
One of the lengths is 24. So the square of that missing length has to be 25 squared minus 24 squared, which means the length itself is the square root of that. $25 squared is 625. 24 squared.
$576.
576. 625 minus 576.
Which one?
625 minus 576.
99. You said 625 minus 526.
576.
49.
What's the square root of 49? 8. 7. Missing length is 7. Sine of theta, opposite over hypotenuse. Cosine of theta, adjacent over hypotenuse. Tangent of theta, opposite over adjacent. Secant, hypotenuse over adjacent. Cosecant, hypotenuse over opposite. Cotangent, adjacent over opposite. Sine of phi. Right, we're now up at that angle. Opposite over hypotenuse. Cosine of phi. Adjacent over hypotenuse. Tangent phi opposite over adjacent. secant phi. Hypotenuse over adjacent. Cosecant phi is hypotenuse over opposite. And cotangent phi, adjacent over opposite. Those two are the same. They're co-functions. Specifically for a right triangle, what is the relationship between theta and phi?
Opposites.
What do you mean opposites?
They're like on. Like their angles would be the same, maybe?
Not necessarily.
Like, no, they're not 90 degrees, so they both. Oh, they gotta both equal 180 minus 90.
That's sum up to 90 degrees. Because the sum of all the angles in the triangle is 180.
Yeah.
With the right triangle, you already have a 90-degree angle. Phi is theta minus pi over 2. So you can see the co-function identities in action here. And cosine theta sine phi should be equal. Right, co-functions. Tangent theta, cotangent phi should be equal. Secant theta, cosecant phi should be equal because they're co-functions. And your cosecant and secant. The other color. And cotangent theta, tangent theta are equal. Those are your co-function identities in action. So that's just a quick verification of your co-function identities.
How would like that look if it was put into like the equation?
What do you mean how it would look?
Like for say like cosine t cosine
Well, it's not times, first of all.
Or just sine pi over 2 minus 2. Like how that look?
Because phi is theta minus pi over 2, right?
Mhm.
So sine theta is cosine of pi over 2 minus theta.
So if you had theta, then you could find sine.
If you knew the angle of theta, then you also know the angle of phi. But really, this just boiled down to a verification. You actually only had to do half of this work because of the cofunction identity. Once you calculate sine and theta, you now automatically know cosine and phi. They're the same. Right, so once you calculate all the thetas, you know the phis using the cofunction identities. We did it out here to verify those cofunction identities. So what is this missing line? Which I'm just going to call the base.
Square root of 2 or square root of 5 squared.
Which is what?
2 plus 5, 10.
Why'd you only square the root 5?
Square root 20 minus 4. So, square root of 16.
So your base here is 4. Sine of theta.
2 over square root of. Do you do? Oh, no, 2 over the. 2 over 2 square root of 5.
Which simplifies to what?
Because don't you have to multiply the bottom line by then the top line? 2 over square root of 5.
2 over 2 is 1, right? 1 over root 5. Or rationalize it, root 5 over 5.
That's what I was thinking, like the.
You don't have to multiply by 2 root 5. You just have to multiply by root 5 over root 5. Cosine of theta.
4 over
Simplify it.
2 over square root
Tangent.
of square root of 2 over the square root of 5. Or no, opposite. That's 2 over 4. You get 1/2.
Secant.
Square root of 5 over 2.
Cosecant.
Square root of 5 over 1. Or just square root of 5.
Cotangent.
2. And then you have your other ones.
What's sine of phi?
Square root of 5. Or no.
Just square root of 5 over 2.
Square root of 5 over 2. No, it's close. It's 2 over square root of 5.
It's 2 over the 5. It's cosine of theta, not secant of theta. Right? Or you could have just used opposite over hypotenuse with phi, right? You could do either one. Cosine of phi.
One over the square root of 5.
Tangent of phi.
Or no, square root.
Secant phi.
Square root of 5.
Cosecant phi.
Square root of 5 over 2.
Cotangent phi.
1/2.
With that relation, we also know that both theta and phi have to be less than pi over 2, right? But greater than 0.
The degree can't be 2.
Well, you count negative degrees, but in a triangle you can't. Which means theta and phi are acute angles, right? Right triangle trigonometry is only valid for acute angles. Which means quadrant 1. So you can't use this technique for non-acute angles. Actually, you can if you're clever. And we'll see situations of that, I believe. The values of the remaining trigonometric functions of the acute angle theta, given that sine of theta is 3 over 7. So, just so I don't have to draw triangles all the time, I'm going to cheat. Good, okay, so that definitely was not right. But let's go on some more. That works. Technology's a beautiful thing. Because it's an acute angle, we can use right triangles. Which one we set as our theta doesn't matter. Let's just call that theta.
Sine is
So how is sine defined?
opposite of our hypotenuse, so opposite is 3, and then the hypotenuse 7, and then the adjacent is going to be square root of 7 squared minus 3 squared.
What's 7 squared?
49,
What's 3 squared?
9, and then 3, and then
It does simplify. $42 cubed times 5, right? Oh, there's a perfect square in there. 2 squared. So you move out a 2, and what are you left with on the radical? 2 times 5. 2 root 10. Now we already have sine, so we don't need to worry about that. Oh, by the way, we actually only have to find 4, because one of them is a freebie. Which one do we know immediately? Just given that sine is 3/7. What other trig function do we know? Cosecant. What's cosecant?
the reciprocal,
Which is
4, 7.
7/3. So again, that's one of those where this was a test question, you got the cosecant wrong, you cried. You probably smacked your head on your desk. Notice, let's do this in green. If instead we chose this to be theta, that's the only thing that will change. But all your trig functions would still be the same. You'd still get the exact same value no matter where you put your theta. That's why I said where you put it actually doesn't matter. What's cosine? So let's get rid of the green so we don't confuse ourselves.
2 square root 10 over 7.
What is tangent?
Seven over 2 square root 10. Oh, 3 over 2 square root 10.
Or 3 root 10 over 20. If you want secant? What's cotangent?
Two square root of standard over 3. Is there like a trick for you or to like memorize which like one is the inverse of cosine and sine?
The reciprocals?
Yeah.
I just know that secant is the reciprocal of cosine. Cosecant I know is the reciprocal of sine. But I've been working with trig so long that I kind of know a lot of the identities off the top of my head. I guess what you could do is you could say secant cosine, one's a co, one's not. So secant is the reciprocal of the cosine. Then cosecant would be the reciprocal of just sine. And then cotangent's obvious.
Yeah.
That's the tangent.
only one with the tangent.
So then those two are reciprocal of each other, but maybe do it that way.
Yeah.
Get acute angles, or an acute angle, so let's just do this. Let's pick that to be our theta in question. Tangent being 1.5,
But then the calculator and make it fractional.
I mean, you shouldn't need to run the calculator to get the fraction. One point five, 1.5. Uh-oh. 3/2. 1.5, 3/2.
And then it's the opposite of what we're using. So there is 5.
Height would be 3. What's the base?
2.
Which means if I really wanted this to be accurate,
3.
if I really wanted this to be to scale, I should do this. Because the height is clearly smaller than the base. But it doesn't matter, right? Because it doesn't have to be to scale. Base is 3, height is 2. What is the hypotenuse? Square root of what?
Square root of 5.
How'd you get the square root of 5?
Square root of 5? Is that what we did then?
How'd you get square root of 5?
Square root.
Oh wait, no, you don't do that. You don't do like, you just do the square root, 3 square root plus, right, instead.
And hypotenuse you're going to have is
So it's 13.
square root of 13. And a quick way to tell that it can't be root 5, hypotenuse has to be the longest length.
Yeah, that
Root 5 is less than 3. So that can't be, that's not possible. Right, because that's another thing about triangles, right, is that the length of the side is related to the angle that is opposite of it. So the largest angle, the side opposite, has to be the largest length. What sign?
It's 3 over the square root of 13.
Good job not getting messed up, because I drew the angle in a different place. It's 3 over root 13. What is cosine?
Two over square root of 13.
What is secant?
The square root of 13 over 2.
Cosecant.
Square root of 13 over 3.
Cotangent. That was the freebie. You said we have to be dealing with numbers. Nobody. So we can also use expressions. And this is going to be extremely important in calculus too.
Using these for right angle? Using this for
Writing expressions for the trig functions. Specifically, the part of Calc 2 where you have to look at trig sub for integration. Being able to then convert your trig functions as expressions is extremely important. They again tell us that theta is a cube.
So if theta was obtuse, it wouldn't be a right angle, or it wouldn't be a right triangle, right?
It wouldn't, the angle itself would be located inside of a standard right triangle. But what you would do, and what I do, is I just look at the reference angle, the angle instead, which by definition is acute. That then lets me set up the right triangle. And then I just use the chart to determine whether it's positive or negative, depending on what quadrant I'm in. So, am I using the right triangle? Yes, but is it for the actual angle? No. It's for the reference angle. So that's why I said you can, if you're clever, you can still use right triangles regardless of the angle. It just requires a bit more thought. Doesn't matter. Let's use this as theta. Opposite, which is the height of the triangle.
2x. And then 3 is the
Hypotenuse is 3. What is the missing length?
that's going to be the square root of 3 squared,
Which is
9, minus the square root of 2x.
square root of 2x.
The 2x, so our 2 is 4x.
for x squared. And that's all simplification we can do.
But it can just cancel out, like,
That cannot be simplified. Remember, you cannot simplify across addition or subtraction.
mm,
It would only go across multiplication, division. Cosine theta. Tangent.
you can't simplify those at all.
Secant. Cosecant was the freebie. And cotangent. Nothing different. Except you're just working with a variable instead. But the process is identical. A few things to note. All of these expressions are going to be defined. Right? For starters, x has to be positive. If it was negative, then this would be a negative length, which is impossible. Second, x can't be 0. If it was, you wouldn't have a triangle. So that takes care of that. Which means you don't have to worry about this. So already x can't be 0. And x has to be positive. We also know that 2 times x has to be less than 3. Which means x has to be less than 3/2. It can't equal, because then again you wouldn't have a triangle. This would then have to be 0. 3/2 squared, 9/4. So at 3/2, this would be 9 minus 9, which is 0. Less than 3/2 means that this is smaller than 9, which makes the square root positive. So all of these are automatically defined. Just based on the definition of your trig functions. Theta is acute, tangent of theta is x.
So that means
Again, it doesn't matter which one you choose to be your theta.
the opposite is going to be x, and then adjacent is going to be 1.
What's hypotenuse?
1x squared, 1x squared, square root of x squared, x squared.
Not just x squared.
I'm trying to do it. Oh wait, no, it's gonna be like x. Yeah, it's gonna be like.
Square root of x squared plus 1. Keep in mind, this triangle is actually representing a unit circle. The base is 1. That means your radius of the circle is 1. Oh, I'm sorry, not necessarily. If I set up the origin, the hypotenuse has to be the radius. So never mind. Hypotenuse has to be the radius when you're dealing with right triangles. So this is not unit circle. That's a shame. What sign?
It's square root of x squared plus 1 over 1, or just x squared. No. So opposite x over, or just x. Yeah. Opposite over g. So
Sign's not opposite over Jason.
So x hypotenuse x over the square root of x squared plus 1.
What's cosine?
1 over the square root of x squared plus 1. That's an adjacent over hypotenuse.
My computer froze.
I got it wrong.
Respond. Let's try this again. We don't need tangent. Secant.
Square root of 1 plus x squared.
Cosecant.
Square root of x squared plus 1 over x. The cotangent is 1 over x.
Cotangent of theta is 1 over x. The sun is 20 degrees above the horizon. How long is the shadow cast by a building that is 50 meters high?
So theta would be 20. So the building is going to be the opposite.
So let's just draw it. So there's the ground.
And the building.
Let's help you from now.
And the sun.
So that's the building, and we know that it is going to be 50 meters.
And then the shadow.
They tell us that the sun is 20 degrees above the horizon.
So that's going to make the hypotenuse.
So let's just say that represents the horizon. That's a good color for the sun. Yeah, that looks like a good color for the sun. That's 20 degrees above the horizon. We want the length of the shadow. All right, let's just say the shadow is going to extend out to there. We'll call that L, length of the shadow. We don't know what it is. That's what we want to find. Let's try and write this now. As a right triangle. Well, what we do know that if you draw that out like that, angle must also be 20 degrees. Right, so from the top of the building to the edge of the shadow has to form a 20-degree angle. So now I need to reopen this. Thankfully, I'd already saved it. Actually, I don't need to reopen it, do I? So let's go ahead and make that happen. I actually don't need you. I can just come back to here. That's 20 degrees. We know that this is 50 meters, and that's what we're trying to find. Which trig function will relate those two lengths?
Tangent,
Or what else?
cotangent.
Right, so either tangent or cotangent.
Do cotangent because so you can do the cotangent 20 equals L over 50 and then multiply 50 by both sides. And then you do 50 cotangent 20. Wait, cotangent is the cosine inverse, right? Oh yeah, that's how you put it in the calculator. You do squared cosine 1 or cosine inverse. Or no, you do 50 cosine inverse 1.
So that would be the exact answer, and that's actually how you would keep it.
Oh really? You want to put it in the calculator?
Because it's not asking you for an approximation. I am going to do one.
I mean, yeah, I put it in the calculator and it said error.
I did, what do you know?
I put 50 cosine inverse 20.
Yeah, no. You're trying to do an inverse cosine, which we haven't covered yet. It's also not inverse, it's reciprocal. And it's not cosine, it's tangent.
Oh shit. Wait, cotangent. Wait, how would you...
Right, so you may have a calculator that actually has all the trig functions in it.
Yeah, it's not.
Ignore this bottom row for right now. Those are the inverse trig functions. We haven't studied those yet.
Yeah.
We will be. 20. Now you have to be careful. Because we want 20 degrees. So you have to make sure that you're actually in the right mode. The Inspire makes it easy.
I would think not. Radian.
The Inspire tells you what mode you're in, right up at the top. This says I'm in radians, so I need to change that to degrees. For the Inspire, there's two ways I can do it. Use the mouse feature, just scroll over it, and then just click. Now it's in degree. Otherwise, let's go to the document. It should be settings and status, and then document settings. Or in a non-MTI Inspire, you have to look for your mode key. Right, you'll see one of them is angle.
You mean put your
Right, You should only have two options. The Inspire has three.
Gradient.
We also have a gradient, which we're ignoring. Now I'm in degrees, so I should get if you do not have all 6 trig functions, most graphing calculators should at least have the 3, sine, cosine, tangent.
Yeah, that's what I have.
Then you just do this. $50 divided by tangent. Because cotangent is 1 over tangent. If you don't have the tangent, you have to write everything in terms of sines and cosines.
Yeah.
Cotangent is cosine over sine.
Or,
Right, so it'd be 50 cosine of 20 divided by sine of 20. If you don't have the tangent key.
or I just saw this too as well. To do it, you could do 50 tangent, 20, and then the inverse key. And then you still get 137.
Well, that'd be raising tangent to the -1. Now it's the same thing.
Yeah.
But you have to make sure that you put the tangent in parentheses, the whole tangent in parentheses, that makes the -1.
But this question didn't ask us to do all that, so we just leave it.
Could also do tangent of 70 degrees, right? Using the cofunction identity.
Yeah.
So there's some way you can get around it.
Mm-hmm.
Now, if this is asking for an approximation, we only have one sig fig. So this one sig fig, that's 100 meters.
Yeah, would it be 137?
137 is 3 sig figs. 50 is 1, 20 degrees is 1. And the exact value, yes, it's like 137 and some change meters. Ladder leans against the side of a building with its foot 12 feet from the building. How far from the ground is the top of the ladder, and how long is the ladder? So it makes an angle of 70 degrees with the ground.
So that means 90 plus 70, and then the other angle is 20.
Let's just say there's our ground. Just make that the side of the building, and we'll say it has a slanted roof. Why not? Let's be a little more artistic than just drawing a line.
That's 12 foot.
say, there we go. There's the ladder being. It says it makes an angle of 70 degrees with the ground. Means that's 70 degrees. And it is what, 12 feet? We want height off the ground, and we want length of the ladder.
I mean,
Height, that's length. Well,
for the height, 10 feet.
my tangent, 70 degrees would have to be height over the 12 feet, right?
Mhm.
So the height is 12 feet times the tangent of 70. That'd be the exact answer. That away from the QR code.
Wait, you don't want us to put that in the calculator?
It's not asking for an approximation, is it?
Or would we be wrong to do it? So that, like,
Yeah, because I'm not asking for an approximation. I'd want that.
how would the question be worded? Like, would it say like
Round your answer
to the nearest?
approximately. And something along those lines. For the purposes of this problem, I am going to get an approximate value just to give you an idea of the scale.
Mhm.
But on the exam question, if it was worded just like that, that is how you leave your height.
Okay.
Or some formula, like you could write 12 times tangent of 70 degrees and then feet on the outside. Right, but you leave it as 12 tangent of 70 degrees. You wouldn't give me an approximation. Again, we're only going to have one sig fig because of the 70 degrees.
Thirty.
30.
Feet.
Yep, 30 feet. Yeah, I'll write out that is indeed only one sig fig. Length of the ladder. I would not use Pythagorean theorem here because it's going to give you too much error. So again, use trig.
You could do
Secant of 70 degrees. Have to be the length over the 12 feet, right?
does that have buttons over there, Jason?
For secant, yeah. Cosine adjacent over hypotenuse secant is the reciprocal of that.
Yeah.
that would be the length, right? 12 times secant of 70 degrees feet. So one sig fig would be 40.
But that, wait, you got 35.08, but it was round to 40?
I'd round that to 40. Really not that useful, so it'd be what, 33 feet and 35 feet if we just kept whole numbers? Something along those lines. From the top of the lighthouse, that is 120 meters above the sea, the angle of depression of a boat is 15 degrees. How far is the boat from the lighthouse? They don't tell us if the lighthouse is located on a cliff or anything like that.
So assume it's on the.
That is irrelevant because it's specifically saying from the top of the lighthouse. So it doesn't matter whether it's on a cliff or not. The fact is the top of the lighthouse is 120 meters above the sea. So without loss of generality, I am going to assume that it is on some kind of platform. You don't typically put a lighthouse with the base in the sea. Right? It's usually on like a cliff or an island, something along those lines.
Angle of depression, that just means.
Let's say that's the sea there. Let's draw a boat. Let's do a very basic boat. Yeah, very basic though, I'm not an artist. 5 more time. 5 more time, I'd throw it in the chat GPT and have it just do a diagram for me. But it takes a while for it to actually load the image. So, let's draw the lighthouse. Lighthouse would be something like this, right? And then has a dome. It looks like a mushroom cloud, but it'll work. Better than what it looks like on my nose. The angle of declination. Right, it's from the top of the lighthouse to the boat. Good enough government work. This angle would be the angle of declination right here. On the top of the lighthouse of the boat. That's 15 degrees, they tell us. We also know that height's 120 meters. We want to find, just make sure I'm finding the right thing. How far the boat is from the lighthouse. And I'm going to assume that the lighthouse is actually right on that base. Right? It's not indented anywhere. So it's right on the base of the cliff. So then this is the length that we're looking for. I'll just call that X.
Is it alright that I call it the D, like for distance?
There upon using B. That really comes out in calculus. So I typically never use it, but you can, doesn't matter.
You could,
There's a ring, this is the right triangle. 15 degrees. This is 120 meters. That's what we're looking for.
you could do tangent. But isn't because I did the other angle. I thought it was from the top.
Angle of declination is from the horizontal.
This is depression.
Same thing. Declination, depression is the same thing.
Okay, I understand that.
Oh, actually, no, declination would be from the top. Depression is from the horizontal. If it was declination, you're right, it would be
Yeah.
with respect to a vertical. Right. So declination would be that angle there.
So if it said like the angle of declination is 15%.
Then it'd be with respect to the vertical.
Okay.
Depression is with respect to the horizontal. And there would be the exact answer. 120 meters times cotangent of 15 degrees. This time we have two sig figs. $450. This one's fun. Find the height of a tree if the angle of elevation of its top changes from 20 to 40 as the observer advances 75 feet towards its base. Now, let's say there's the ground.
There's going to be a word trigonometric doesn't test.
Could be. Big tree. Just like green leaves. Okay. Make it a really leafy, bushy tree. That's lopsided. Maybe it's windy that day. Who cares? Serves the purpose. Angle of elevation was originally
20%.
oh, I drew the wrong one. Drew the wrong one first, but that's okay. It was originally 20 degrees, increased to 40 degrees as you move 75 feet towards the base. I guess I want to draw. Red, don't go all the way. That's 20. That's 40. We want to find the height of the tree, right? That's what we're looking for. And we know this length here. We know that one is 75 feet. Well, let's call that remaining distance x, right? So the distance from our new observation point to the base of the tree is now just x. Then we know the cotangent of 40 degrees has to be h divided by x, right? We also know that cotangent of 20 degrees has to be h divided by x plus 75. First one. So starting to run slow again. So quickly check CPU usage. Yeah, okay, so there's no problem there.
X cotangent 40 then?
I did those backwards, didn't I? So I did those backwards. Save. Actually, let me try rebooting PowerPoint. I'm starting to run slow. Oh, PowerPoint crashed. At least it was just PowerPoint. All right, that first equation tells us that x is h times cotangent of 40. Now we just plug it in. Solve for h. And these should all be feet. I'm not going to write it down. That means h would be 75 divided by the cotangent of 20 minus the cotangent of 40 degrees. That's the height of the tree. We only have one sig fig. Right, 20 is 1, 40 is 1. I'm going to just put decimal places at the end. I'm going to say, assume that we know that it's exactly 40 and exactly 20. So 2 sig figs. Be 48 feet. So just make sure that you can put that into your calculator and get right around 48 feet.
For the second part where you moved, I'm pretty sure you moved the h cotangent 40. You subtracted that from both sides, right?
And I also factored out the
Then you
at the same
factored
time.
out the h.
Yeah, so I just did that in one step for the sake of space.
Okay. And then
And I don't want to risk a crash. So I was trying to write it in as few strokes as possible. It seemed to be fine, but I didn't want to risk crashing. Okay. Are there any questions on right triangle trigonometry? Just as easy as a circle, right? And they said trig was hard. Okay. So don't forget, your second exam is Monday. Bring everything with you. Okay? Make sure you bring your calculator, make sure your calculator is charged. Bring that reference sheet, bring a pencil or black ink pen. The exam will work the exact same way as it did for the first exam. Have a good weekend. See you for the exam.